Hello, everyone. You are welcome to today's class. In this class, we're going to look at motion under gravity. We're going to look at motion under gravity. So when an object is thrown upward, when an object, say a stone, is projected upward, or an object is released from a height, right? So its motion is governed or affected by gravity. So an object thrown upward experiences a negative acceleration due to gravity. So when an object is thrown upward, because it is against the direction of what? Of gravity, it will experience negative acceleration due to gravity. But when an object falls down or released from a height, the acceleration due to gravity is g, because the motion is in the same direction as that of the gravitational attraction of the Earth. Are we together? So we are going to use the famous theory equations of motion, but with a little modification. The first one is V equal to U plus AT. The second one is V squared is equal to U squared plus 2AS. The third one is S is equal to UT plus half AT squared. So we're going to use this, but there are some certain modifications here. So for a body that is thrown upward, a body thrown upward. So our modification will look like this. We're going to apply this. So our first equation will be V is equal to U, because it is thrown upward. Remember, the G is negative. So I have minus. Instead of A, we use GT. That is first equation. The second one, we are going to have V squared is equal to U squared, because it's thrown upward. So G is negative. It will be minus 2GH. Our distance here, horizontal distance here, become the height, the vertical height. So U squared minus 2GH. Are we clear? And the last one will be, instead of S, we use H. The height is equal to UT minus half GT squared. So this is it. So when a body is thrown upward, then depend on how the equation is, then you can use any of this equation using negative. So the second one is for a body falling downward. For a body falling downward or released from a height. So the difference is just negative, positive. So when it's coming down, G is what? Is positive. So our first equation will be V equal to U plus GT. Second equation will be V squared equal to U squared plus 2GH. And the last one will be H equal to UT plus half GT squared. I hope this is understood. So we have the usual representation of each of these. V is the final velocity, U is the initial velocity, G, which represents the linear acceleration, is now acceleration due to gravity and is constant, 9.8 meters per second squared, and T is the time, H is the height in meter, and the usual unit applies to each of the parameters. Is that understood? So what you need to understand, to remember, is when an object is thrown upward, right? When an object is thrown upward, first, you should know that the final velocity on getting to the height, let's say this is the height, this is the height. Assuming this is a tall building, this object is thrown upward. On getting to this, its final velocity, V, is equal to 0. On getting to its maximum height, the final velocity is equal to 0. Is that understood? Now, again, for an object that falls from a height, if this object falls from a height, right? If this object falls from a height, the initial velocity is equal to 0. The initial velocity U is equal to 0 when the object falls from a height. But when the object is thrown upward, on reaching the maximum height here, the final velocity is equal to 0. These are hidden information that might not be given to you explicitly. So you need to get it from this so that you know when V is 0 and when U is 0. Also, the third point you need to remember is that the time it takes an object to travel upward is the same time it takes to come down. If this object moves from here to the maximum height at what? Maybe the total time it takes the object is 2 seconds. It's 2 seconds. It will also take that the same time for the object to return to the ground, 2 seconds. So we call this time taken to reach the maximum height. Then the time it takes to reach the maximum height plus the time it takes to return is known as time of flight. It's known as time of flight. Time of flight, which is equal to, can call it capital letter T, which is equal to T1, the time it takes to move up, plus T2, the time it takes to go up. Remember that T1 is equal to T2, so you can have T1 plus T1. So the time of flight is equal to 2 times time it takes to reach the maximum height. Are we together? So time of flight, if assuming I have 2 seconds to reach the maximum height, then time of flight will be 2 times what? 2 to give us what? 4 seconds. That is the total time is spent on the air. Are we together? So those are the 2 points you need to have, 3 points you need to have at the back of your mind while solving question relating to motion under gravity. Now, that being said, let's move to work examples. So example 1. So the question says, calculate the maximum height a ball of mass 1.2 kg will attain if projected vertically upward with an initial velocity of 17 meters per second. So the body is projected vertically upward. Take note, vertically upward. What do we say will happen? There are 2 things we said will happen. The first thing that we say will happen is that when an object is projected vertically upward, let's say data, or given that, when an object is projected vertically upward, we say the final velocity V is equal to 0. Take note of this first. The moment you see vertically upward, calculate the maximum height. You're looking for maximum what? Height. You're looking for H. Right? Given that what? The initial velocity U is equal to 17 meters per second. What else were we given? Remember that your G is always constant. Sometimes it's 9.8, but most of the time you use 10 meters per second squared. 10 meters per second squared. So you're now looking for what? Looking for the height. So this mass is just given to you. It doesn't have uses in this calculation. So don't allow yourself to be confused with this value. Are we clear? So in that case, looking at VHUG, you ask yourself which of the 3 equations we need to use. And since it is vertically upward, so I have the 3 equations. V is equal to U plus or minus GT. I have V squared is equal to U squared plus or minus 2GH. And I have H is equal to UT plus or minus half GT squared. Ask yourself, it is plus when the object is what? Coming down, and it is negative when the object is what? Going up. Now, here our object was going up, vertically upward, right? So we are going to apply negative. Now, the next question is, which of these formula that we can use, considering the parameters we have here? So I have V, H, U, G. So which one that contain that? Here, there is no V, so I cannot use it. Here, there is V, there is U, but there's no height. I cannot use it. So the one that I can use is this one. There's V, there's U, there's G, there's height. So this one is applicable. So now the next is, I already consider it, since it's vertical, I'm going to use negative. So my formula now would be V squared is equal to U squared minus 2GH, because the object was projected vertically upward. Is that clear? So that being said, we now have, what is our V? 0 is equal to U is given to be 17, then we square it, minus 2 times G, which is constant, multiplied by H, the height that we are looking for. So what is 17 squared? I have 0 is equal to 17 squared will give us 289 minus 2 times 10, that will give us 20 times H, that will be 20H. Now, this one crossing the equality sign change to minus 289 is equal to minus 20H. So minus, we cancel minus. That implies that we have 20H is equal to 289. So divide both sides by 20. We have H is equal to 289 divided by 20. And that should give us 14.45 meter. 14.45 meter as our height. I hope this is understood. So if you are new to this channel, please do well to subscribe to this channel so that you'll be among the first to get my video each time I upload a new lesson. Thank you for watching. See you in the next class as we continue to solve more questions that are likely to come in your as you prepare for your exam. Thank you very much. Check out for the next examples.